Welcome to AP Calculus, Section 3.5, Derivatives of Trigonometric Functions, page 1. We're going to start here with f of x is equal to sine x, and we want to find f prime of x. We don't have anything that we can use right now to do this, so we need to go back to the limit definition of a derivative, which is f prime of x is the limit as h approaches 0, f of x plus h minus f of x all over h, and our function here is sine, so we'll use f prime of x is the limit as h approaches 0, sine of x plus h minus sine x all over h. We have to expand out this sine of x plus h. You remember from pre-calculus, the sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So we have the limit as h approaches 0, sine of x cosine h plus cosine x sine h minus sine x all over h. And nothing can factor out of all three of these. We can, however, factor a sine x out of the first and third terms here. Leaving that second term at the end. All right, now I'm going to separate this one fraction into the two separate fractions that would have added together to make that. So we'll have sine x times cosine h minus 1 all over an h plus cosine x sine h all over an h. Now, to evaluate this limit, we need to remember some of our limit rules, which allow us to separate and evaluate limits over addition and multiplication. So if I expand this out, we have the limit as h approaches 0 of sine x times the limit as h approaches 0 of cosine h minus 1 over h plus the limit as h approaches 0 of cosine x times the limit as h approaches 0 of sine h over h. And evaluating each of these limits here, this limit, the limit as h approaches 0 of sine x, there's no h's in there to plug in, so that is just sine x. This limit is a memorized one. Actually, you memorized this. The limit as x approaches 0 of 1 minus cosine x over x. You memorized that earlier this year as equal to 0. Well, this is just the opposite because we've reversed the order of the subtraction, but it doesn't matter. Opposite of 0 is still 0. So this is times 0. That one was memorized. This one, again, the limit as h approaches 0 of cosine x, there's no h's in there, so that's just cosine x. And this one, again, was a memorized one from earlier this year, and that's 1. All of this pulls together, and we are left with cosine x. So, long and short of all of this says that the derivative of sine x is equal to cosine x. Please memorize that. One of these problems over here kind of got lost in our work. Clearly there's not enough workspace here to do this same process to find the derivative of cosine. So we're going to go a different route here. And I want you to use your calculator. So there's no glare on here for you. Oh, there we go. All right, so first thing, let's put in y equals cosine x, and I want to turn that equation off. So I arrowed back over on the equal sign, hit enter. Now notice that equal sign is not highlighted. It will not graph. Go to your window, please. Set the window to be negative 2 pi for the x's all the way up to 2 pi. Oops. Scale, let's go with pi over 2. Y's, we'll go negative 4 to 4 with a scale of 1. And if I go ahead and graph right now, we see nothing, which is exactly what we should see, because while that equation of cosine x is typed in there, it is not, it's not to be graphed. It's accessible to the calculator, but we're not graphing it. All right, now go back to y equals, and down here in y2, we're going to graph the derivative. So alpha f2 n derives number 3 d dx. Now you want to put y1 there, so we take the derivative of y1. That we can find under alpha f4. And we're going to find this at x equals x. That tells the calculator to find the derivative of every single x coordinate, every single x value within the window that we chose. So when we graph, and it does graph rather slowly because, again, the calculator is running the symmetric difference quotient at every increment through here, and there's approximately 100 increments through here. So your calculator just went through 100 symmetric difference quotients. And we get this graph. Looks like sine, but it's not sine, because sine would normally start at the origin and goes up first and then down. So this is y equals negative sine x. What that means for us over here is that the derivative of cosine x is opposite sine x. Please memorize that one as well. All right, now how about all the other ones, the other trig functions? Tangent, cotangent, secant, and cosecant. Well, let's see if we can figure out from the graph, since we had the calculator right here. So what I'm going to do is go back in here and take out cosine x out of y1 and change it to a tangent x. That turns the graph on. I don't want it on. I want it to turn it off. That way it's accessible to the calculator, but I won't see it. And now when we graph this one, I'm going to graph y2. It's still graphing the derivative of y1. It's a different equation in there, but it's still looking at that derivative. Looks like this. Partially recognizable. Looks like it might be a secant, but remember from last year, secant had one of these U shapes going up and one of them going down, and up. They were alternating. This has got everything going up, and it's really not like an absolute value of secant or anything like that. It's a variation. So we're back to having to do some work here to figure out this derivative. And instead of doing the limit definition of a derivative like we did up here for tangents, let's take that tangent and rewrite that as sine divided by cosine. Now we could use a quotient rule. Bottom, cosine, times the derivative of the top. Derivative of sine is cosine. Bottom to the top minus top. Sine times the derivative of the bottom. And the derivative of cosine is negative sine. over bottom squared. I'm cleaning this up a bit. We'll have cosine squared plus sine squared. Oh, how nice is that? All over cosine squared, which gives us 1 over cosine squared x, or secant squared x. So the results of this tells us that the derivative of tangent x is secant squared x. Memorize. Last 3 of these, the cotangent, the secant, and the cosecant, can all be derived by doing a quotient rule. Cotangent, we would do cosine divided by sine, and then a quotient rule. Secant, we would do 1 over cosine, and then a quotient rule. Cosecant, 1 over sine, and then a quotient rule. In the interest of saving some time here, let's look at these derivatives. Let me just give them to you. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant x tangent x. And the derivative of cosecant is negative cosecant x cotangent x. And yes, you need to memorize these as well. There's a couple of patterns you can notice to help you. All of the original functions that start with C, cosine, cotangent, cosecant, they're all the negative derivatives. Those 3 are negative, the other 3 are positive. Also, secants and tangents always stick together. So it's a derivative of secant, secant tangent. Cosecant, negative cosecant cotangent. And the t functions, the ones that have a t in it, tangent, and cotangent, t, they're the ones that have a 2, starts with a t, as a power in here. If those little tricks help you memorize, then use them. If you use something else, that's fine too. But however you learn them, you need to memorize these 6 trig derivatives. Thank you very much. Please join me on page 2.